suck, Nick. You suck, Nick. You suck, Nick. You suck, Nick.
Hey guys, welcome to Talos of Space. This is Nick. Hopefully my microphone is working this time, and unlike last week. Thanks so much for joining. This is going to be a live stream reaction to the commercial resupply mission that we're sending up to the International Space Station. SpaceX and NASA just went live together, which is always kind of fun when they do that. Do a simultaneous live stream, and so we'll tune into that right now, and we'll see exactly what they're seeing. So currently we have 22 minutes and 20 seconds on the clock, and we are going to be filling that time, hanging out in the chat, saying hello to everybody, and just enjoying this launch. So this is the 22nd commercial resupply mission that we have had with SpaceX to get up to the ISS. These commercial resupply missions resupply the International Space Station with all of the implements that they need, like cargo, basically scientific experiments, upload and down, up mass and down mass. So it's kind of exciting to see them launch another one of these. The initial commercial resupply contract that SpaceX got only included 20 commercial resupply missions. And just a few years ago, that ran out, and SpaceX has been renewed to this new version 2 contract where they get to use all of the existing hardware again. And I believe that this is the first flight of this Cargo Dragon. I believe it's their 5th Cargo Dragon model, or unit, I guess. And so it's their 5th one, and it's going to be its first flight. And I believe this is also a brand new booster. So very exciting to see that we have so much new hardware going up into space. And obviously this is almost all 100% reusable. With the Cargo Dragon, things that are not reusable include the trunk section and the second stage. But other than that, everything is refurbishable and reusable. That means that SpaceX gets to reuse this Falcon 9 that they just made. I believe it's a BN69 maybe. Anyway, don't quote me on that. It's in the high 60s of the Falcon 9 boosters that we're working off of. And so very, very exciting to see that we have this going up. I want to say hello to anybody in the chat. Hello, Yusuf. Good to see you. Welcome, welcome. Excited to have you. And Jonathan, hello. Hi. Welcome. Feel free to chat any comments, questions, concerns, all that fun stuff here. We're here to hang out and enjoy this SpaceX NASA live stream because, boy, there's some stuff to cover here. Going up on this is about 3,300 pounds of cargo. And included in that, there's going to be some fresh fruit for the astronauts. A lot of people don't realize that getting fresh fruit or fresh ice cream or anything fresh basically is a really rare occurrence up on station. So every time that they send up one of these cargo missions, they make sure to include some fresh fruits and veggies, and on occasion even more exciting things like ice cream if they have freezer space on the upmass side. Something that makes Cargo Dragon unique from other resupply programs like the Progress resupply missions, they are only upmass, and so some of these other programs only allow upmass. They don't allow downmass. And since the Cargo Dragon, I don't know why I'm doing this. Cargo Dragon, since Cargo Dragon is refurbishable, they kind of fish it out of the ocean, which means there is some downmass capability, meaning that they can load up scientific payloads that have been on station for a while and return them to Earth for further analysis. So this has really enabled NASA and SpaceX to be able to partner in a way that that just brings a ton of value to the space program and space community in general, scientific community at large. Being able to downmass, I believe, almost 2,000 pounds of cargo is fairly impressive. So yeah, that's what we got going on here today for the launch. It was almost scrubbed about an hour ago. We're looking at no-go weather conditions. But as of right now, the range looks clear, weather looks holding, so we'll see if we get a weather scrub later today, and if we do, we'll be back here whenever the next launch is. So again, super excited to have you guys join along. Let's take a look at these beautiful views. Oh man, we got the NASA commentator. I do not know if we have just, there we go. Yeah, all right. Let's see. I just want to get some nice rocket views. I know this isn't going to be live, but we'll just look at these beautiful rockets. Beautiful day down in Florida, and just with the clouds and the blue sky, it's going to be a gorgeous launch. I can already feel it. And yeah, this is down on Slick 39, I believe. Yeah, that's Slick 39. That is where most of the Apollo missions went off from. So that's always kind of exciting to see SpaceX reusing that same launch pad decades and decades later. So the Falcon 9 booster is obviously going to be doing a return kind of profile where they're going to get it back, unlike a lot of other rockets that we send up that we never see again or have to do a ton of refurbishment. These Falcon 9 boosters are known for very reliably landing on drone ships or back on land to be refurbished and reused on other missions. This Falcon 9 booster is brand new, as I had mentioned, so it has never flown before, and it's looking nice and beautiful, nice white, just non-carbon score, just it's looking clean. And this particular Falcon 9 is going to be landing on the drone ship. I believe, of course, I Still Love You should be in position out about 800 miles off the coast of Florida. And it is positioned downrange so that the Falcon 9 can not waste too much fuel. The Falcon 9 booster will lift the payload with the second stage up to an altitude of 30 kilometers or so. I don't remember exactly when staging happens. I'm not a super professional space nerd. I'm only a kind of a space nerd. It takes it up to a certain altitude, and then we have our staging occur. And after staging, the Falcon 9 booster then continues its ballistic trajectory to basically this drone ship out in the middle of the ocean. Now, you might have seen some Falcon 9 flights or even Falcon Heavy flights where the booster returns back to the launch site. That's what's called it uses what's called a boost back burn, where they use extra propellant to nullify the ballistic trajectory and fly it back down. And unfortunately, that's kind of a propellant heavy maneuver, and so SpaceX doesn't want to do that if they can avoid it. It definitely makes more sense to use the ballistic trajectory and just use a drone ship, just from a payload to Delta V comparison. So let's hop back live here and see if we get some more live views, and if not, we have more commentators. I am commentating on a commentator commentating on a live stream here, so I don't know about that. Let's hop back here to the main screen. Looks like there aren't many people saying hello in the chat. Obviously, feel free to chat. We're just hanging out. Question for you guys to answer if you want to. When do you think we will see Starship go orbital? That's a big question that DJ and I were talking about on the Space Podcast last night, which should be going up very shortly here on this channel. When will Starship finally go orbital? And so you can feel free to answer that. I'd love to have a discussion about that as we wait here for our CRS-22 mission to go live. Okay, so I think I've kind of monologued here for a minute. We're going to take a quick break, and we will be back with more coverage.
You suck, Nick. You suck, Nick.
All right, and we're back from that little break. Appreciate you guys hanging along here. We have no news updates. Weather is still holding. Range looks good, and we're just waiting around for the countdown to go to 0. Currently, we're sitting at 12 minutes and 20-ish seconds by the time the YouTube live streams get synchronized. So we're getting awfully close to this CRS-22 launch coming shortly. Be right back.
suck, Nick. You suck, Nick.
Oop, sorry about that. Welcome back. Thanks for joining us on this CRS-22 launch coverage. Super excited to see yet another cargo dragon take off from planet Earth and arrive at the International Space Station. Super excited to see this launch go through, and obviously we are sitting here at about 9 minutes and some change. Just getting excited for the launch. NASA and SpaceX are doing a co-live stream right now. So right now we have NASA and SpaceX commentators commentating on different things. So we're not getting those pretty rocket views, but from what we can tell, everything is still go for launch. Range is good, weather is good, and the vehicle itself is healthy. Wanted to give you guys a little bit of context about the payloads itself. The entire entire cargo dragon and trunk and everything together in it weighs about 6,000 pounds. The usable cargo volume is about 3,000 pounds of cargo. Broken up inside of that, we have our science and investigations and about vehicle hardware. Science and so we have 750 pounds of crew supplies. We have 115 pounds of spacewalk equipment going up, another 128 pounds of computer resources. So maybe they're getting some M1 Max on the ISS. That'd be kind of fun. And then the biggest chunk here is the external payload, because the CRS-22 mission is actually going to be carrying the rollout solar array. So this is going to be a solar array which is going to be able to be rolled out, and it's going to provide even more power to the station. As the station gets older and those solar panels get older, they become less efficient, so it becomes more difficult for the station to maintain its power needs. And so this rollout solar array is going to be here to provide a little bit of supplemental power, and also to test out some new technologies on rollable solar panels, and kind of keeping that flexible. So we have this whole rollable solar array that's going to be going up today, which is pretty exciting. We'll see that be deployed over the next few weeks here, and hopefully it will be reliable and provide some good power to the whole spacecraft there. Of note here is definitely the fact that this is the first time that this specific cargo dragon is actually flying. We haven't had any. Actually, I just checked the live stream here real quick. We have some pretty good views of what this rollable solar array is. If I go back just a little bit, so this is the rollable solar array that's going up on the cargo dragon here. It's actually stowed in the trunk section. So it's an unpressurized area behind the pressurized capsule. It's kind of between the solar panels that you'll see on the Dragon. And so this is going to be mounted on the space station, this rollable solar array, and it's going to supplement the power from the main solar panels that you see there. So you can see that's a pretty big solar panel installation. It's not small. Hopefully the Canada arm is still functional. I haven't heard anything about that. I would assume that they were planning on installing this with the Canada arm. And obviously, we just had news a couple weeks ago of the small puncture that happened to the Canada arm. Sitting at about 7 minutes here, we are still go for flight, it seems, and we are getting ready for our launch here in under 7 minutes here, which is pretty exciting. So as I was saying, this is the first flight of this actual capsule, this Cargo Dragon. It is a new model here. It is a Dragon C209 is the serial number on this Dragon. It's also mated with a brand new booster as well. Kind of rare at this point to see a brand new Falcon 9 fly. Falcon 9s are obviously very reusable, and so we're kind of used to seeing reflown Falcon 9s doing the heavy lifting around here. But for one reason or another, this is a brand new Falcon 9. I wanted to say hello to folks in the chat here. Hello, Fake Leo. Excited to see you. Thanks for waving. Appreciate it. Hope all is well with you and yours. And then Yusuf said, I don't think it's going to happen in July, maybe not even August, probably the fall, referring to my question about the Starship orbital launch test. And so, yeah, that's definitely definitely out there. Elon is famous for saying, yeah, we're gonna have this up next month. I believe with SN1, or what would they call it before the SNs, but when they did that first he did the was it Mars update or whatever, and standing in front of like the very first full stack Starship prototype, he was like, yeah, this thing is gonna fly next month. And like it took them almost a year to have another version that was flyable. And so anyway, yeah, Elon time is never good. He's pretty optimistic about fall. I've been tracking the news down there fairly closely. My best guess would be late July at the very earliest. I would definitely say in mid-August we'll be pretty close. But I think the fall is definitely the safe bet for the first orbital flight of the Starship. Mr. Mike, why Mike joined the chat. Hello, Mike. Good to see you. He says, I'd say uncommon rather than rare. That's true. Uncommon is possibly a better word to use when you have a brand new Falcon 9 booster. But at the end of the day, it's kind of crazy that all of this is like brand new stuff. Like we're so used to just reflown stuff, and just a few years ago that was kind of unheard of to have a major orbital class booster that was reflown many times. So we're sitting here in just under T-minus 5 minutes to the launch of CRS-22, and all looks healthy with vehicle. The weather is still holding, although we did about an hour ago have a no-go situation with the weather. Hopefully weather does not violate anything going forward here. We've got some nice rocket views. Let's show some nice rocket views. Ooh, look at that. Look at all that venting. So that all those clouds of smoke that you see coming out of that was Mark 1. Thank you, Yusuf. Yeah, so it's Mark 1 prototype that Elon gave that speech in front of back at Starbase, Texas. Back then it was called Boca Chica. So we have our strong back is either retracted or just about to retract. It's kind of, there it goes, retracting right now. Strong back is retracting. That's where the clamp that holds on to the very top of the Falcon 9 booster is released, and then the whole tower, you can see it releasing right there. It is releasing, and then the whole tower is going to tilt back about 2 degrees to prepare for launch. And as soon as launch happens and liftoff occurs, the whole strong back is going to swing backwards and allow the Falcon 9 to pass it without touching anything. So we're definitely getting close to launch there, and you can see those white plumes are condensed oxygen. So inside of the tanks there's about 1 million tons of propellant between liquid oxygen and RP1, rocket propellant 1. That's basically like a really refined kerosene or like a really refined jet fuel. And so it's pretty much, just like regular gasoline, but like super refined. So there are not very many impurities in RP1. But those white clouds that you're seeing are venting from the liquid oxygen tanks. Liquid oxygen needs to be stored at like negative 200 degrees Fahrenheit, somewhere thereabouts. And unfortunately, those tanks are pretty thin on the inside of the Falcon 9. They don't want to waste a bunch of space or weight with insulation material. And so what they do is they pump in this negative 200 degree oxygen, which is in a liquid form when it's that cold, and it touches the sides of those to the liquid oxygen, the sides of the tank at room temperature feel like extremely hot because oxygen at room temperature wants to be a gas, and so it will actually boil off from those tanks, and so that's what they have vents at the top there that is letting out all the liquid oxygen. It's a no smoking zone. Would not go smoking around that. I guess at this point there probably aren't any humans, seeing how there aren't any humans on the rocket. There are not any humans for 5 miles around this rocket. This is a great view of exactly what you would see if you were there, because you'd be standing on the top of a building about 5 miles away. And they do that because you never know if something's going to go wrong. And when something goes wrong, you don't want to be too close to it. All right, we are less than 2 minutes away from countdown here. At T-1, that's a beautiful view right there. At T-1 minute, we're going to have engine startup. I'm sorry, computer startup. So the whole startup system is going to be engaged at 1 minute. And T-1 minute, and that is where the flight computers are going to take control of the final countdown, and just basically report back to ground about what's going on. And so that'll happen in about 20 seconds here. We can see the water deluge system at the top of that SpaceX water tower to the right of your screen is deluging some water. It looks like maybe it's overflowed or something, but hopefully that's all nominal. I would imagine it is, because our countdown clock is still counting down. All right, Falcon is now in startup, which means that the onboard flight computers have taken control of the final countdown. We are getting close here. I wanted to say hello to anybody in the chat here before we launch. Mike says, teeter-totter squids. Appreciate the tongue twister there. Grant says, you said to say hi. Hello, Grant. Thank you for saying hi. Appreciate that. And stay tuned for another 30 seconds here, and we'll watch this this beautiful CRS-22 mission take off, hopefully from the pad 39A. And we're at T-minus 15 seconds mark, and we are getting ready for liftoff. 9, 8, 7, 6, 5, 4, 3, 2, 1. There it goes! Whoa! Wow, there it goes! Woohoo! Go SpaceX, go NASA. Wow, awesome. There it goes. Man. All right, so you see it's picking up speed there. It's measured in kilometers an hour. Oops, sorry, my face is over that. Let me fix that here. Put my face like right there so you can actually see what's going on there. Sorry about that. You can see the telemetry down in the corner there where it says speed, 400, 500 kilometers an hour. This is obviously picking up a ton of speed. We're already at 2 kilometers, 3 kilometers of altitude. Falcon 9s just really take off the pad. Look at those beautiful views. I love some of these kind of backwards facing views where you can see just a little bit of the rocket trail, the plume from the exhaust plume, and then that beautiful blue ocean and clouds. Apparently we're flying through some clouds here. Wow, that's great. All right, we're approaching max Q, which is going to be the point where the body is going to be experiencing the maximum aerodynamic pressure throughout the entire flight. It's right before it breaks the sound barrier, and after that, it will be at all the pressures will be released. Okay, it looks like we have a max Q call out, so we are past the point of maximum aerodynamic pressure, which means that it's all smooth sailing from here, barring any technical difficulties, at least from the pressures. We will continue to follow along here. MECO will be happening in about 60 seconds. But we just watch these rocket plumes expand. If you've ever wondered why the rocket plume starts real small, like you just rewind this video about a minute, you'll notice the rocket plume was really small and you couldn't see much of it from this angle. But now that we're kind of up here, it's getting a lot bigger and it's going to keep growing. The reason why that happens is because the pressure is going to be less the higher up you go. Obviously, when you enter more of a vacuum, it's going to be a little bit less pressured. Which means that we can expect to see the plume expand a little bit more, which is actually why we have multiple different engines. So on the Falcon 9's booster, we have sea level Merlin engines, but on the second stage, we have a vacuum optimized Merlin engine, which we're looking at right now. I just switched away to a very confusing cloud tracking cam. Looks like we're having MECO right about now, so that's when the main engines are cutting off. There we go. We have a main separation here. And then we're going to begin our boost back burn because this Falcon 9 booster is going to be landing right back at the pad. Kind of a rare occurrence for this to happen. Ooh, we got to even see some of the rocket plume in that camera angle. That is kind of cool. So yeah, we have Falcon 9 returning back to base here with this boost back burn. I'm not sure why we're not getting a ton of live stream coverage from the booster, unfortunately, but second stage seems to be appearing nominally at the moment. We have its speed is picking up. You'll notice that most of the speed to get to orbit, you need about 28,000 kilometers an hour of speed, and we're at about the right altitude, about 100 kilometers. Obviously, it'll get up to about 200 kilometers for the ISS's orbit, but most of the speed is going to be happening with this second stage engine here, which is just basically one of the engines on the first stage. All right, so it appears that we are performing the boost back burn as we speak because Falcon 9 is decreasing in speed. Looks like you can see those hot gas or cold gas thrusters going off, and kind of see the grid fins deploy. Those grid fins are actually about the size of a dinner table, so those are not small. They're definitely pretty big. They look kind of small just because you lose so much perspective, but you can see it slowly guiding itself back to the pad. In about a minute and a half or so, we'll have a reentry burn of the Falcon 9 booster, and then we'll have shutdown in about 90 seconds or so of the second stage. You just watch that speed climb so fast on the stage 2 telemetry. It's just so impressive that it just picks up, it's almost exponential how much, because you're in a vacuum of space, there's almost no drag, and it's just constant thrust that's just expanding and accelerating over time. So kind of fun to watch that. Like, we were at 8,000 kilometers an hour. Now we're 9,000 kilometers, 9,500 kilometers an hour. Just keeps moving up. And this view that we see on the left here, which I'm partially covering up, apologize, is actually of the interstage. So I'm not really sure why they're showing us that, of the inside of it's where the bell that we're seeing on stage 2 was actually sitting inside of the top of this first stage there. Okay, we're about 5 minutes here on the clock. Everything seems to be performing nominally. Not seeing any anomalies from anyone on the Twitterverse here, so that's good. Yeah, let's continue to enjoy this stream here. Beautiful stuff. So now we can see the altitude decreasing on the stage 1 telemetry. It's definitely coming back down. It's picking up speed. So at its apogee, it was slowing down because it was kind of peaking out, and it was still gaining altitude. But now we're losing altitude, and we're going to be gaining speed. And so it's going to be this entry burn here, which is going to start up any second. It'll shave off a good amount of that speed. There we go. There's the entry burn. So now we see that speed is just plummeting, as well as the altitude. So both the altitude and speed are plummeting, which is good because we want both altitude and speed to meet 0 at the exact same time. Otherwise, we get a kaboom. And this one's doing a boost back burn to the pad, so definitely don't want to have a scary big boom here. Okay, looks like the entry burn has been completed. We are now in the thicker parts of the atmosphere, kind of cloudy or overexposed. Can't see what's going on with Falcon 9 at the moment. We're down at 9 kilometers, 8 kilometers, 3 kilometers. So we're just minutes away from landing, seconds away from landing burn at this point. There we go. I think I'm seeing some ocean here. Ooh, you can see that drag right there on the, wow. You can see the drag right on those grid fins. All right, 3 kilometers. Coming up on it. Ooh, landing burn. There's the drone ship. I see it. There's the drone ship. This is some clean coverage, guys. This is some clean coverage. Drone ship right in sight, on target. It's looking nice and straight. Oh, this is going to be nice. Speed's coming down just right. Yep, here we go, here we go, here we go, here we go. Yep. Oh, there we go. Nice! Good job, SpaceX. Nice job, Falcon 9, for yet another on-target landing right on that little drone ship. Of course, I still love you. We'll keep watching here for the Stage 2 telemetry. Looks like we've hit our target orbit of around 200 kilometers just for this initial insertion orbit. Obviously, there'll be maneuvering stuff. We're still looking to hit about 28,000 kilometers an hour or so to hit orbit, but we are definitely getting close. I'm sorry, CJ. I did probably need to move myself. That was definitely a beautiful landing. Let's see here. It's coming up to Seco. We're getting there. 25,000, 26,000. Just the thousands of kilometers an hour just keep stacking up. It's kind of cool. Like right before you hit orbit, 27,000. All right, we have Seco at 27,010 kilometers an hour. Now we're going to be waiting in a little bit of a parking orbit here, waiting for the next phase of the burn here before we do any kind of deployments. All right, so that is it. I think we got a little bit of a wait here. So I'm going to go ahead and sign off this live stream. It was good to see you guys. Thanks for joining for this fun little stream. Good to hang out with you guys and just say hello and have some fun. Hopefully learned something and had some fun too. See you guys next time for the next SpaceX launch, where we'll be covering whatever other things they decide to send up into space. Congratulations, Elon. Congratulations, SpaceX. Congratulations, NASA, for what appears to be a successful launch of the CRS-22 mission. See you guys next time, and Godspeed.